So unfortunately I am recording this video in school and there's a lot of noise in the hallway, but can't really do anything about that. So I put the data in the calculator and I ran the 1 var stats, and this is what I got. So in fact, if you look at, remember, standard deviation, I told you it's this, right? The big S and the X. It actually is 1.59 if you round this to nearest hundred. So count was on point. I just wanted us to double check, no big deal. Gonna do the same thing, excuse me, I'm not gonna do the same thing actually for the bottom. We'll trust that this is also the standard deviation for the bottom. But what's really interesting is that you need to understand, what does that number tell you about this data, right? So like, what does it mean that the standard deviation is 1.59 and that this standard deviation is like bigger? Like this one's almost 3. This one's like half of 3. What does that mean? So this is what it means. So let me see if I can write on this. Yes, I can. So make sure you copy this down. If you have a smaller standard deviation, okay? So when I say smaller, I mean like if you're comparing it to another one, okay? So like this, if we're looking at 2. The smaller the standard deviation is, it basically means that all of your data are not that far away from the middle, okay? So the middle, in this case, is that black, I don't know if you guys can see like that black line right there. That's the middle of this data. It's actually the mean, I believe. Let me just double check. So it could be the mean or the median. Let me just go back and check real quick. No, it's actually the mean. You see how the mean is 4.9? So if you go back to this, that number is like not exactly 5, it's almost 5. So this is the mean, okay? So this is X bar. Same thing, this is X bar. It's just that the mean here is obviously bigger because the two data are not the same, right? Like they're different. So the standard deviation being so small in this one, it means that most of your data are closer together to the middle. Is that okay? To the mean, to the center. So that's what I'm gonna write here, and you should write that down too. The smaller the standard deviation, this means that your data are, now I'm gonna use some, math language. It's not that fancy. If they're closer together to the middle, then the data is not spread out. It's less spread out. Now, if something is less spread out, look at what that means. It means that everything seems to be more closer together to the center. In this case, the center that they're using is the mean. In this case, you can see it there, it's the mean. Sometimes the center that people use is the median, and I'll tell you in the next video, when do people use the median for the center? In this case, they're actually using the mean, so don't confuse it. The center, it doesn't always have to be the median. It could be the mean sometimes. In this case, it's the mean. And this is the reason why. Do you see how our data, for the most part, thought I could write. Doesn't that pretty much, doesn't it look symmetric? Kind of, right? It doesn't really look that skewed. Even this data, it's not perfectly symmetric, by no means. But this data doesn't really look super skewed. This data doesn't look as symmetric, but it is still sort of symmetric, sort of. It's not that symmetric. You have to kind of like argue with me that it's not perfectly symmetric, but this data is not really that skewed either. When your data is sort of symmetric or close to symmetric, you should use the mean as the center. So I'm gonna write that here, okay? So the mean could be the center if your data looks close, sorry about that, looks close to, and then close to what? It should look close to symmetric. Okay? Alright. Anyway, so standard deviation, going back to that. If that number is smaller, then most of the data is actually really close to the center, to the mean in this case. So that's what I'm gonna write here. The less spread out, if it's not that spread out, everything is closer together. And again, the center could be the mean or the median. It just depends. In this case, it's the mean, okay? Okay, it depends. Now, what if the standard deviation is bigger? So like, what if it's larger? The value here, the standard deviation here for this data is that. This is almost double that. Now look at what the data appears to be. Guys, does this one look less spread out, or does this one look more spread out? It's more spread out, all right? So why is it more spread out? Because the standard deviation is larger. So basically, the standard deviation controls the spread of your data. That's what it does. The bigger that number is, the more spread out it is. The smaller that number is, the closer it is, the less spread out, okay? So I'm gonna write that here. Now, again, your data will be more spread out. Okay? Which means that a lot of your data are not that close to the middle. So most of the data, if you look on this side, they're kind of far away from the middle. They're like over here. And then most of the data is like towards the left, not really towards the middle. But over here, a lot of the data was towards the middle, towards the center. So hopefully that makes sense. You might need to watch this video like 5 times if you process things a little slower. But that's what standard deviation does. It controls the spread.